So now we understand normal curves and we understand how far away data values are on a normal curve if we know their standard deviation and their mean. But what happens when we want to compare two different data values from two different distributions? So, for example, we've got this example below that's Ella and Alicia, and they're taking two different tests. One took the SAT and one took the ACT. And they're trying to figure out who did better on their test because the SAT has a different scoring system than the ACT, right? So the SAT is going to have a different mean and standard deviation than the ACT is, right? So what equivalent score on the SAT is as good as the score on the ACT? That's basically what we're trying to figure out. Or you think about heights, right? Men and women have different heights. So the mean height of women might be different than the mean height of men, right? And we're trying to figure out in comparison who is really the taller of somebody. So, it's like, am I taller than 75% of women, or is my husband taller than 75% of men? Like, who's truly the taller of us, even though I'm shorter? So the idea is we're taking two different data values from two different distributions. So in this case, we're going to do the ACT and the SAT. So the one distribution is the SAT. The other distribution is the ACT. One has one mean and a standard deviation. One has a different mean and different standard deviation. And we want to see how they compare. And if I could put those two distributions on top of each other and then figure out where each of those values was, which one would be a higher value. That's really what we're doing, okay? So what we have to do is we have to do something called normalizing or calculating a z-score. So there's the z-score, and it's the standard score, which basically tells us how far away from the mean any value is. So it tells us how many standard deviations away from the mean it is. So if a number has a z-score of 1.5, that tells me that that specific number is 1.5 standard deviations away from the mean for that distribution. For example, we look at our ACT-SAT example. If 35 had a z-score of 2.7, that means that if you get a 35 on your ACT, you are 2.7 away, or 2.7 standard deviations away from the mean. Does that make a little bit of sense? I hope so. Okay, so when we're calculating a z-score, again, we're trying to figure out how far away something is from the mean, how many standard deviations it is away from the mean. And then we can compare, right? Because that would tell me if I am 1.5 standard deviations above the mean for heights for women, and my husband's only 1.3 standard deviations away from the mean height for men, that means I am taller in comparison to other people of the same gender. Okay? So let's figure out how many standard deviations away from the mean each of these scores are, which means we're going to calculate the z-score. And once we've calculated the z-score, that's going to tell us whose score is at what place on the normal curve. Okay, I'm going to stop talking. We're going to do some math. All right, so the way to calculate a z-score. The z-score is, you take whatever the value is that we're looking for the z-score for. Okay, so this is the data value. That would be like my height or your SAT score or the number of siblings you have. Any of these things can be the data value that we're using. We're going to call it X. You subtract from that the mean. Okay, so this is, remember, subtraction is just finding the distance between two numbers. So all we're trying to do is figure out how far away from the mean is your data value. But we want to figure out how many standard deviations it is away from the mean, not just how far away it is, right? Because if you get a 32 on your ACT and the mean is 21, we know that's 11 points away from the mean, but that doesn't tell us anything in comparison to other things. So what have we got to do? We've got to divide it by our standard deviation, because that tells us how many standard deviations away it is. Okay, so we take the value, and I'll write this out in words, value minus the mean divided by the standard deviation, and that's going to give us a z-score, which tells us how many standard deviations away from the mean is this value. Okay. Took me 5 minutes to say all of that, but I hope that it's clearer, because I remember calculating z-scores in statistics and they would be like, well, just standardize this curve. And I was like, I have no idea what you're doing. And I would just like calculate it without having any clue what I was doing. So hopefully you understand now. Okay. Ella and Alicia, let's figure out. Here's Ella. And she took the SAT and got a 1380. And then Alicia, she took the ACT and she got a 32. And they're super competitive. I don't know, maybe they're twins. They're just competitive. Don't be competitive. Anyway, they're competitive and they wanted to just see who had a better score in general. So if we could think about a standard or a normal curve of SAT scores, it's going to have a mean of 1,000 with a standard deviation of 200. So the next value up is going to be 1,200, and then the next value up is going to be 1,400, and so then we're going to go to 800 and 600, okay? Now let's think about a standard or a normal curve for Alicia, for the ACT. The ACT has a mean of 21 with a standard deviation of 5. So that means 26 goes here, 31 goes there, 16 goes there, and 11 goes here. Okay, so Ella sits right about here with a 1380, and Alicia sits right about here with a 32. Already you might be able to tell just by looking at this and thinking about the empirical rule and realizing that Ella's is not quite 2 standard deviations away, and Alicia's is more than 2 standard deviations away. But why would you go to all this trouble every time, like having to actually do that? So let's just calculate their z-scores, and it'll tell us exactly how many standard deviations away they each are, okay? So I wanted you to see it graphically. Now let's do this algebraically. So remember, our z-score is going to be the value, which is 1380, minus the mean, which is 1,000, over the standard deviation, which is 200. Now this one's the same thing, the value minus the mean over the standard deviation. So we're going to plug those into a calculator and be right back. I want to point out, when you're putting this into a calculator, make sure that you put parentheses around the top, because remember, order of operations tells us to divide first. So if you don't put parentheses around the top, it's going to divide these and then it's going to subtract from here, okay? So make sure you do everything on the top and then divide it by the bottom. So we have a z-score of 1.9 and 2.2. This means that, is that Ella? Ella's score is 1.9 standard deviations above the mean because it's positive. And then Alicia's score is 2.2 standard deviations above the mean. So hers is higher. Now what you might be thinking is, what if their score was lower than 1,000? This would be negative, right? Well, yeah, that's totally okay. You can have a negative z-score, because a negative z-score tells us that we're below the mean. So instead of Ella being up here, Ella might be down here. And so you're maybe trying to figure out who has the lower score. And so you might have a negative. But in this case, we had 1.9 and 2.2. Therefore, Alicia has the higher score in comparison.